Hey guys, I wanted to show you how to do what we call a free body diagram here. So we've got this block here, and Chris is pushing to the right on the block, and Pam is pulling to the right on the block, and in the description it says the block doesn't move. And so the block is going to be represented by this dot, and we want to draw forces on this dot that represent all the forces up here on the block there. And we want to clearly label them. And it also says that we want to start the tail of the arrow on the dot and point in the direction that the force is acting. And it also says draw longer arrows to represent bigger forces. And we can use this grid here to sort of gauge how long our arrows are. So what are some of the forces on this block right here? Now you maybe have drawn your own drawing, but let's go over now what the correct answer is. So one force is the force of gravity. So I'm going to draw an arrow down here for the force of gravity, and you got to give it a label. You could call it W for weight, or lots of times they'll write a F sub G for force of gravity, or just a G. I'll write a W there just so for weight for now. We've got another force that we talked about in class when we did field of forces. If you push down onto the table with your hand, you remember, you'll feel the table pushing back up on you. So the block pushes down on the ground and the ground pushes back up on the block. Another way to think about this is there's a tug of war going on. Gravity pulls down and yet it doesn't move down. So there must be something else pushing back up. This upward force, you could write F sub N. I'm just going to write an N, where N stands for the normal force, the force of two surfaces pushing into each other there. Now notice I've drawn the normal force and the weight the same length here. Whether I drew it 2 blocks long or 3 blocks long or 1 block long, it doesn't really matter. The point here is that I drew the weight the same length as the normal force, which means these two forces are the same size. And I know that because it's balanced vertically. It's not moving down or up. So those two must cancel each other out and how strong they are. So another force that we have is Chris. Now, some people want to draw Chris over here, but remember it says draw the tail of the arrow starting on the dot. So Chris is pushing it to the right. So we're going to start our tail here, and I'm just going to make this up and say Chris is 2 blocks long. I'm going to call this F sub C for force of Chris there. Now Pam is pulling to the right as well. And so I'm going to draw an arrow coming out here. I'm just going to make it 1 block long. And again, you could have made these different blocks long. I'm just making this up as I go. Now, you could call this F sub P for Pam or called it Pam. I'm going to call it T for tension. And so because she's using a rope to pull on it there. So Chris is pushing to the right and Pam is causing a tension to the right, and yet it does not move. So once again, there's this tug of war here and nobody's winning. So there must be a force back the other way, canceling them out. What could that force be? So that force is friction. And lots of times friction is symbolized with a little sort of italicized lowercase f. You could write F sub lowercase f, that's often used as well. So notice I drew the tension 1 block and Chris 2 blocks, so that all together the rightward force is 3 blocks. There, I also drew the friction 3 blocks. I know that the backwards force here has to cancel the total forwards force right there. So one more quick bit here, I'll answer the other question that says stop to discuss with the group, and then you guys will finish the rest of the worksheet here. So student 1 and student 2 are having an argument. Student 1 says, I think the free body diagram for the block should have a force by Chris, a force by the rope, and a force by Pam. So 3 forces there, Chris, the rope, and Pam. And student 2 says, I don't think the diagram should show a force by Pam. People can't exert forces on blocks without touching them unless you have the force. So which student do you agree, if either, do you agree with? I think most people think that student 1 is wrong, that especially this part like having a force by the rope and by Pam, like that doesn't seem right. It's got to be one or the other. And this person says it can't be Pam because she's not touching it. So she's not quite right either, student 2. So if we look at it here, this force here, you could call it the force by Pam, or you could call it tension, meaning the rope's doing it. You can think of it as either, but you can't think of it as both. So it's not Pam and the rope. You can either think of it as Pam or the rope, and it's got to be one or the other. And I've chosen to think about it as the rope as tension there. So now that you've seen sort of how to do one of them and the idea of balancing them and how long to draw the forces there, work on the rest of the worksheet and then check out the video with the answers where I go over the rest of the worksheet. If I can stop this video here.